Alright, matrices. Matrices is just another way to arrange data or data to look at it in different ways. A matrix is a rectangular arrangement of numbers that put up in rows and columns. You have to have like a nice number of numbers to put in rows and columns. Like this first one, the only way I can rearrange it in a row of, I mean, there's no way I can put it in a 4x4 or a 6x2 or something. And we name matrices by their dimensions, first by the number of rows and then by the number of columns. And an element is just a number in the matrix itself. So go ahead and example 1 says to state the dimensions of each matrix and then identify the position of the circled element in them. So when we're naming matrices, you first name the rows. The rows go this way. How many rows does this one have? 1. And how many rows? 1 row. How many columns? 3. So you always go rows, then columns. So we would say this is a 1 by 3 matrix. Really?
That's all we do.
Yep, and then it starts to name the element in the matrix. So I would say, okay, which row is this circle thing in? 1. Okay, so it's in the first row, what column? 2. So second. Seriously? I told you would just all go backwards. How easy it was. Yep. Alright, B. If I was going to name the dimensions, what would we say?
3 by 2. 3 by 2.
3 by 2. 3 rows, 2 columns.
And then third row, first column.
Can you do like R?
My dog can do this.
Oh, you can write out the words.
Come on,
Oh, this is such an easy assignment. You want to
yeah,
make
it's
it
gonna get the easiest assignment. Well, this is like the articles in grammar. And that's that is like a process.
Alright.
The articles.
Okay, so 2 matrices are equal if and only if they have the same dimensions, meaning they are the same size, and each element of one matrix is equal to the other. So in other words, these 2 matrices are equal because they're exactly the same. These 2 matrices are not equal because they're almost the same except this one has a 4 in the top corner and this one has a 3. So therefore they are not equal. These are not equal, even though they have the same numbers, and this guy has a column of 0, they don't have the same dimensions because this one's bigger, therefore they're not equal. If 2 matrices have the same dimensions, they have the same size, then we can either add or subtract them. And to add or subtract them, you're just going to add or subtract the corresponding elements of the 2 matrices. Really super simple. Okay, example 2 says we have matrix A, B, and C, which will find the sum of the difference, and if the sum does not exist, write impossible. So with this first one, they're asking us to add matrix A and B together. So here's matrix A, here's matrix B. First we have to say, are they the same dimension?
Yes.
Oh, yes.
Yeah.
Yeah, because if I was going to name the dimensions, this one would be a
2 by 3.
2 by 3, 2 by 3, and this one would be a 2 by 3. So can I put them together? Yes, I can. Here's how we're going to do it. It says to add them, so we're just going to take the top left corner plus the top left corner. What's 6 plus 7? 6. So we have 10 in the top left corner. Okay, now let's add. Bottom left corner plus bottom left corner, negative 1 plus 1?
0.
So 0 goes in the bottom left. Okay, then let's do the middle top. Negative 4 plus a negative 4? Negative 8. 6 plus 6? 7 plus negative 2? Yep, right. And 0 plus negative 3? Good. That's it.
So what's the point of
matrices? When you are working with lots and lots and lots and lots of numbers and you work with matrices, it's a lot easier to do it if you put them in arrangement so you know which ones go where. It's more of a geometry thing. This is just kind of an intro, so when you get there in geometry, you're like, oh yeah, I remember those. Basically.
Yeah.
I don't know. It'll come back.
I'll imagine this being something not hard to relearn, though.
No, it's not. It's not. All right, now they're asking us to add B and C.
Impossible.
Impossible. Why? Right. Not the same dimensions. If you were going to try, you could like add these four with these four, but then these are nothing to add with it, so you can't do that. Alright, and then they ask us to subtract A and B. Can we do it?
Yeah.
Yes, we can. So you're just going to take element in A minus B. So 3 minus 7.
-4.
-1 minus 1.
-2.
-4 minus a -4.
0.
Good. 6 minus 6.
0.
7 minus -2.
9.
And 0 minus -3.
3.
Just don't forget to put your brackets around things there. And notice when we're out there subtracting, we still end up with the same dimensions. We started with 2 by 3, and we end up with our answers of 2 by 3. Thoughts?
Really easy.
Told you. You guys never believe me when I say that.
Yeah.
That's not our math.
And you know all
Yeah,
the way
but
to calculus,
It's
so.
easy. Alright, scalar multiplication. Each element of the matrix is multiplied by the same number, and this number is called the scalar. So in this case, they're giving us matrix T, and they're asking us to find 3T. So they're saying 3 times the matrix T. So all we have to do is take all of the numbers in matrix T and multiply them by 3.
That's good.
So -4 times 3 gets us
-4.
0 times 3,
0.
3 times 3,
9.
2 times 3,
6.
1 times 3,
3.
and -6 times 3.
-18.
So that would be 3T.
Huh. I'm confused.
Okay, then we're going to talk about histograms. So histograms is just another way to show a frequency table, and the frequency table just shows the frequency, or meaning the number of times something happens or appears. Like we could do a frequency table of girls versus boys, because there are, how many girls in a room? How many girls in a room?
6.
6. I'm a girl. So there are 6 girls and how many guys?
2.
2. So I can make a frequency table of girls and boys. So if I would have histogram, I put a 6 and then I put a 2. So basically a frequency table is like a histogram.
That's
Histogram is just a form.
What?
So a histogram. They would be nice. They would be cool. Bar graph in which the data are arranged into equal widths, equal measurements. What's my word I'm looking for? Equal somethings. Equal intervals.
Oh, that's true.
Equal intervals.
Okay.
Alright. Measurement classes is the range of the data values, and the frequency is the number of the values. So they're giving us a histogram to look at. If we were going to look at it, notice it has a title on the top telling us what it is. Along here, it tells us the frequency. That's how many are in each category. Down here are the categories. So we've got seasons for an average. We've got categories from 20 to 25, 25 to 30, so on and so forth. Each bar represents how many times. So in this case, this bar goes up to, looks like about 5. So I think there are 5 seasons that are in between the 20 and the 25 range. Does this make sense of how they're doing it?
Yeah.
Yes? Okay, alright. So these are the different categories. We call these the classes, or the measurement class. So the measurement class in this case is 5 points, because each one is 5 points in width. So they're just breaking it down into 5-point intervals. Frequency is how many times, so they're just going to take how far the bar is above. So in this case, I guess this one, yeah, this is 5. So this one would be about 19 or 18. This one is going by 2s, I think, 22. So the frequencies are just how many times it happens. If we add them all up, it's going to tell us how many seasons total are 13. Questions, comments on how they're reading this? Okay. Example 1, so we got populations of counties in Maine in 2000. It asks us in what measurement class does the median occur? I know it's been a while since we talked about median. Got mean, median, well, what's median? The middle. So we want to know where the middle is. So in order to do that, we have to figure out exactly how many we have, right? Well, they're telling us already here. There's 7 in this group, there's 4 in this group, 3, 1, 0, 1. So let's just add them all up to figure out how many numbers we have.
16.
Is it 16? Okay, so there are 16 numbers all total together. How can I find the middle one?
Divide those by 6.
Divide by 6.
Yeah.
That's the average. Divide by 2.
Oh.
Right, we want to divide by 2 to get to the middle, which would be 8. That means if I was going to line up all the numbers in order, I might have 8 over here, and I've got 8 over here. My middle's going to be in between there, right? So the middle's going to be between 8 and 9. Okay, the middle's between 8 and 9, the values.
Oh my goodness.
So then if I look over here, okay, here's already 7. Where's 8 and 9? The next group, right? Here's 7. That's almost 8. Then I've got 7, 9, 8 and 9 are going to be in between here because I've got 1, 0, 1, 3. So I've got 5 of my numbers over here. I've got 7 over here. So the middle's going to be in here. Anybody confused by that?
I am, yeah.
Okay. All right. So, let's see. If I was going to just label this guy as a 0, and this one is 50, and this one's 100. So this is telling me I have 1, 2, 3, 4, 5, 6, 7 zeros. Okay, I've got 4 50s. 1, 2, 3, 4. I've got 3 hundreds. 1, 2, 3. Got 1 150. I don't have any 200s, but I've got 1 250. Okay, so then if I was going to say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The middle is there, right? Middle, median, has to be somewhere between here and here, right? So that tells me that I know it's in the 50s. Does that help?
Yeah.
Awesome. All right. Next thing they want us to do is to describe the distribution. Help me out.
Distribution.
Thank you. Of the data. Can't read today, so my lap. All right. So it's asking us to just kind of look at the table and tell what it's telling us. Well, just looking at it, what do you know?
Most of the counties, or the majority of the counties are 0 to 50.
Yeah.
Or 0 to 50,000.
All right. Most population in counties are between 0 to 50. Okay. What else do we have? What kind of sticks out just looking at it?
The numbers.
The number 0. Yeah. I would say no counties have a population. Alright, just say that one. Between 200 and 250. Okay, what else?
The number 7.
Okay, well, we kind of have this already. We said most counties are between 150 or 0 and 50. Anything else stand out?
There's only 2 large populations.
Okay.
150 to 200. 250.
I'm going to point out one more thing. Notice how most of our numbers are over here on the left, and like you said, there's not very many over here on the right. This is when we call the data is skewed. If the data is skewed, it's like I take it, and if I was going to pull it like a piece of taffy, it's going to be thinner on one end than the other. So pull it, it's like I'm pulling it to the right. So I would say that the data is skewed right.
So it's less.
I was taking it and it's going to be skewed, like the tail, they call it. I was thinking about if you're going to just pull it like a taffy, it's skewed towards the down. All right, any questions on so far?
No.
All right. Next thing says, which group of students has a greatest mean height? The ones in group A or the ones in group B? So again, how are we going to find the median? We did that on the other one.
Add them all together.
Okay. So how many numbers are in this first group?
4,
4, and then 6, and
8, 7, or yeah, 8.
okay, and then
5, and 4. Or,
And then
1.
okay. So all that together gets us
27,
28, 27, 28. So if we divide by 2,
14.
so I'm going to have 14 on one side and 14 on the other, so I want it to be between
14.
14 and 15. So where are the numbers 14 and 15? Well, let's think. Here's 4 plus 6 gets us plus another 8.
That'd be in 14.
Would be the big one because this is already 10. If I add another 10 plus 8, this is already 18. So I know it has to be in between, so it's going to be in here. So it's going to be,
How do you find that?
okay, so if I add, I have 4 numbers over here in this first group, and then I've got 6 in this group, right? So I've got 10 over here. Then if I add the next one, it's 8. So I get already to 18, but we want between 14 and 15, so it has to be here, because this is only 10, so it has to be next one. All right, let's do in this next group for group B. If we add them all up, we've got 2 and 3 and 5 and 6 and 7, or no, let's see, 8 and 7.
31.
So we divide it by 2.
15.5.
Sorry?
15.5.
So we know that our middle number, we actually have a middle number, it's not between anything. Our middle number is
15.
15?
0.5.
15.5. Okay, this is telling me that I've got 15 and a half going this way and 15 and a half going this way. What's my middle number? 16. Yeah, it's gotta be 16. Our middle number is 16. Okay, so where's 16?
150 to 160.
150 to 116.
Yeah.
Okay, how do you know?
Because if you have an alarm,
Okay, how did you get there, genius?
oh, I have 170 to 180, 160 to 170, 150 to 160.
Okay, sure, we can do it that way. I would do
And that's what
another side, but yeah, sure. Because we have 7 plus 8 gives us 15 plus another, well, we're looking for 16, so it has to be here. So, yeah. So medians between in our interval 15 to 16.
That's a great.
Yep.
I got it.
Because the bigger the increase.
Fine. Well, there's a lot.
All right, last line. Says we're supposed to create a histogram shortage of the bottom scores for a 50-point mathematics test. So our steps, first of all, is to figure out our biggest and our smallest values. So
40.
47.
Oh, 47.
47 is our biggest.
Yeah.
Okay.
23 is the lowest.
23 is the lowest. I think
22 is 22.
22. Yeah, that looks like it's almost there. 22 to 47. Okay, so then I would round. I would round this guy down to about 20, and I'd round this guy to about 50. So now we have to think, we're going to chop it into intervals. Like if we look back up here, these intervals are in groups of 10, because we go 120 to 130 is a group of 10. Back here, they did groups of 5. Here they did groups of 50. So we have to figure out what would be the best to chop our data into. Fives? I'd probably chop it into 5s. So our width would be 5. Because we're doing 50 points here. Alright, so then we need to make a table real quick and figure out, alright, so we've got the category, our smallest is 22, so we're going to round down to 20. So from 20, I'm going to put S for score. And then, so we're only going to go 5 points, our next will be 25. So then we have another interval, we'll go 25 to 30. And then 30 to 35. 35 to 40. Score. 45. And 45 to 50. Notice I have 4 equals on the left and just less thans on the right. This is telling me that I'm putting everything from 20 up to 25, but I'm not including 25 in this first interval. 25 is going to go to the next one. So if they had a score of like 24.9, you would still end up in our first category. Does this make sense? Mm-hmm. Okay, so then we just have to figure out how many are in each category. I think it's easiest to do tallies first. So I would say, okay, 40 is going to go into this one, so I'm going to make tally marks. 34 goes into this one, so I'm going to make tally mark. I'm just going to keep crossing off and putting into the categories here. So this is the longest and most tedious thing ever, but it's got to be done.
These 30, 6, 7.
Yep. So once you got them tallies, I would add them up to figure out how many are in each. Okay, have we got up so far?
And you just got to draw a graph, right?
Now we just have to draw a graph. Yep. So first what I would do is I would put a label. What's going to be our label?
Score.
Scores.
Yeah, I'd say math test scores. Okay, so then we're going to need to make some bars here. Oops, kind of cheap.
We're doing that actually. I don't know.
What does it mean?
Well, we said our biggest and our smallest, so 22 to 47, so we said 20 to 50. So, or not 20, 50, excuse me, goes this way. We need to go from 2 to 8, or 1 to 8. So I'd go 0 to 9. So 9.
What should we do about it?
Okay, and how many intervals did we chop our data into?
6.
1, 2, 3, 4, 5, 6. So we're going to need 6 spaces, so we're going to need 7 lines.
Why is it moving down like that? Wait, what are these ones for?
These are our categories. So we're going to have like scores between 20, 25, 25 to 30, 35.
How many?
Well, how many do we need? How many categories do we have?
6.
1, 2, 3, 4, 5, 6. I need 7 lines. So 1, 2, 3, 4, 5, 6, 7 lines. So down here I would write scores. Insert something. Over here is going to be frequency. Label.
Wasn't it like 23 or something? And you have to make 23 lines? You have like a frequency of 23.
Yep.
That and that fun.
Not really. So this is, oops, we're starting with 20. So 20 to 5, 5 to 30, 30 to 35, 35 to 40, 40 to 45, and 45 to 50.
We're not gonna have a lot of these, are we? So it's just one.
I think I can. Maybe 2, but I think it's 3.
They're not hard, they just take a long time.
And then the fun part is to shade in. So our first category had 2, shade into. And there's some. Okay there.
Yeah.
That's scary. Really scary.
Anything else? Looks like really weird snares.
Any questions, comments?
We need to figure in the